Subraj is there. Hello, Subraj. How are you?
Sir, good evening. How are you, sir?
Fine, thank you. You were with SRM, right? For some time.
Sir? Yeah.
SRM.
Now I'm retired, sir. Now I'm retired.
Okay. Are you in Chennai or have you gone back to Chennai?
Sir, I'm in Chennai only.
Okay.
Professor Bhatt was my teacher in IIT.
Yeah.
He taught me algorithms.
Oh, good.
Using Pascal.
Subraj
for PhD.
Subraj was in quality control, SQC, is it? Something like that.
SQC, but we were in the same department, sir.
Yeah.
We were in DOE that time. He was HOD computer science. I was working there itself as a scientist.
Yeah. He's also author of a book on software reliability.
Yes, sir. Yes, sir. Yes, sir.
Which he was nice enough to send me a copy and I've used it.
Professor Bhatt was a great teacher like you.
Oh, thank you.
But I remember one statement made by him. He said, I'm a very free person. I don't decide what to teach today.
Mr. Rajanaman, good evening.
Good evening. Yeah.
Professor Rajaraman is on now. Yes.
No video though. Yeah, he's there. Good evening, sir.
Recording a few minutes. Just wait for a few minutes.
Sir, shall we start?
Yeah, we can start now.
Agila ma'am, you can put
Akila, you
record.
can streaming, recording, you can start.
Namaskaram, Mrs. Rajaraman. We see you by this side.
Yeah.
Okay. Sir, shall we start, sir?
Yeah, I'm ready.
Okay. Good evening. On behalf of the organizers of today's evening book launch and presentation event, CSI, ACM, IEEE Computer Society and PHI Learning, I have great pleasure in extending a warm welcome to the guest of honors, Professor C.R. Muthukrishnan, the author of the book Software Design and Architecture Engineering, Professor Chandra Bhatt, Ms. Shivani, Senior Editor at PHI Learning, the publisher of the book, and all the participants joined us in the virtual meeting as well as watching through the YouTube streaming. Well, there had been a debate whether the software is an art or science. It was portrayed as an engineering discipline in late 1960s. From then on, the field of software engineering has grown manifold and has been influenced by different technologies. The impact of software in everyday life need not be stressed here, since all of us are in some way or other using multiple software applications and being benefited. While numerous books have been written in software engineering, the book, The Software Design, Architecture and Engineering, which is getting launched today, is different in many ways. You will hear more about this from the author, Professor Bhatt himself, after its launch. We are privileged to have Professor Muthukrishnan, a well-recognized faculty and advisor in the field of software engineering, as the guest of honor to launch the book and to facilitate the author. We are also honored to have Professor to give a presentation on the subject overview and trends in software design, architecture, and engineering. I wish to thank Mr. Ashok Ghosh, the Chairman and Managing Director of PHI Learning, for supporting our initiatives, namely the book launches and author presentations through their editorial staff, in particular Ms. Shivani and her team. Further, our thanks to PHI Learning for offering the free content, the excerpts from the books, and extending special discount on the cover price to the registered participants. Now it is my pleasure to formally introduce both our guests. Professor C.R. Muthukrishnan, known to friends, colleagues, and students as CRM, is in the field of computer science and information technology for about 5 decades. He was the topper in BTech program at IIT Madras and the recipient of President's Medal. He obtained his PhD in computer science and engineering in the year 1969 from IIT Kanpur. His work experience comprises of 30 years as professor of computer science and engineering at IIT Madras, during which he had held positions of head of the department, dean academic courses, deputy director, and director in charge, and numerous other positions, along with member of the board of governors. He has been a visiting professor at Wichita State University, research scientist at Carnegie Mellon University, and visiting professor at the University of California, San Diego. He is a life member of IEEE, fellow of Computer Society of India, Lifetime Achievement Awardee of CSI, and senior professional member of ACM. He has been on the IT task force of Tamil Nadu government, headed by the Chief Minister, member of the Indo-French Scientific Council, member on the board of Indian Bank, Tidal Park, Chennai, and Carrier Limited. He has been a resource person for the National Board of Accreditation. And he was a full-time consulting advisor in Tata Consultancy Services, reporting to the CEO from 2003 to 2010. Krishnan, co-founder of Infosys Limited, has established Professor C.R. Muthukrishnan Chair for Computational Brain Research with a corpus of 10 crores at IIT Madras. He consults for startups, corporate advisor for educational institutions, and is a mentor for many of his former students who have developed startups and grown them successfully. Coming to Professor Pramod Chandra Bhatt, he was a recipient of Government of India Teacher Training Program during the year 1962 to 1965. He formally started his teaching career as a lecturer in 1965 with IIT Kanpur. In 1969, he moved to IIT Delhi, where he was a professor in the Department of Computer Science and Engineering till 1996. He has also taught at universities in Germany, Canada, Japan, and UK during his visiting assignments at Dartmouth University of Konrad Jews Fellow during 1991-92 and Pettibone during 1996 and 1997 in Germany, Ottawa and McGill during 1983 and 93 respectively, both the universities in Canada, and Kochi University of Technology in Japan during 1996 and 2000. He has also spent time in the UK as a British Council Fellow at University of Manchester Institute of Science and Technology during 1972 and 73, Brunel University during 79 and 80, and Queen's University, Belfast during 1983. His long teaching career ended with Indian Institute of Information Technology at Bangalore during the year 2001 and 2003, followed by at Indian Institute of Science, Bangalore from 2004 to 2008. As a consultant, he worked with ABB, Accenture, CDOT, ECIL, IBM, IP Infusion, Philips, Polaris System, Satyam, Sharp, Softgin, and Virident Systems. The nature of consultancy work was largely R&D, futuristic product development, and establishing centers of excellence besides training at higher level. IIT Delhi recognized his services by giving him Distinguished Service Award, a Muther Award in 2011. He also received NODIS Award for lifetime contributions to teaching and research in computer science during the year 2019. Apart from the book Software Design, Architecture and Engineering, which is getting released today, the other books authored by him include Operating Systems, Concepts and Practice, published by PHI Learning, which is now in the 5th edition, and also co-authored a book on cloud computing, Concepts and Practice, published by Springer. Now it is in 2nd edition. So with these words of introduction, now I would like to request Professor C.R. Miss Shivani, Senior Editor, PHI Learning, to give a address about publishing this book and why they have selected this book to be published through PHI Learning. Following that, Professor CRM will formally launch the book. Over to Ms. Shivani, please.
Yeah. Thank you, Mr. Mohan. I really appreciate the introduction. Good evening, everyone. On behalf of PHI Learning, I welcome all of you to the virtual launch of our book, Software Design, Architecture and Engineering, Concepts and Practice by Dr. P.C.P. Bhatt. It is a great honor and pleasure to address all of you today on the occasion of the virtual launch of the book Software Design, Architecture and Engineering, published by PHI Learning. It is indeed a privilege for me to represent and speak on behalf of PHI Learning. PHI Learning Private Limited, under the leadership of Mr. Ashok K. Ghosh, Chairman and Managing Director, is well established today as a leading academic publisher brand in India and abroad. We specialize in publishing high quality, affordable, higher education textbooks as required by higher learning institutions for students worldwide. Our motto is helping teachers to teach and students to learn. Since 1963, PHI Learning provides tools for teachers and students to make teaching and learning easier for them. We have played a significant role in the dissemination of learning through our print books and ebooks. In our journey of 58 years, we have worked with 2,000 authors and published more than 5,000 titles written by them under the imprint Eastern Economy editions in a wide range of subjects. We promote homegrown publications worldwide and also have publishing partnerships with the world-acclaimed university presses like MIT, Microsoft Press, and other international publishers too. We have published university-level high-quality textbooks in all branches of engineering like civil, mechanical, electrical, electronics, computer, and chemical, and so on. The sciences like biology, physics, chemistry, mathematics, humanities and social sciences, and other elite areas, that too at an affordable price to cater to the needs of Indian students. It has been our pleasure to host the virtual book launch event for the fourth time in association with the Computer Society of India, Chennai chapter, ACM Chennai Professional Chapter, and IEEE Computer Society Madras Chapter. The book Software Design, Architecture and Engineering Concepts and Practice, which we are launching today, is Dr. Bhatt's second book with us. His first book published by us is on operating systems, titled An Introduction to Operating Systems, Concepts and Practice. It is widely adopted and is being followed at premier institutes like IITs, NITs, and several other technical universities as well. To learn more about the contents of the books, you may visit our website www.phindia.com. The Google preview is also available on our website, along with the sharing buttons that allow you to easily share the textbook details with your peers and the broader academic community via Facebook, Twitter, email, LinkedIn, and so on. Dr. Bhatt is one of our authors who is associated with us for nearly 2 decades now. He has rich teaching and research experience in computer science and has received the Know This Award of Excellence recently for his contributions to teaching and research in computer science. Written in a simple and easy to understand manner, this textbook, which we are going to release today, aims to prepare students and practitioners for software design and production. The book, by and large, meets the requirements of students at all levels of computer science and engineering, information technology, for their software design and software engineering courses. Like our other published titles, this book is also available in ebook as well as print book formats. Those interested in ebook can either go for Adobe Digital Editions or Kindle Edition. All our ebooks are interactive and are compatible with all devices so that one can read them anytime, anywhere, on any device, whether online or offline. The book is available for purchase through PHI website www.phindia.com and leading distribution platforms like Amazon, Google Play Books, Barnes and Noble, Flipkart, and so on. I encourage you to visit www.phindia.com and our social media pages to learn more about our published books, new arrivals, and forthcoming titles. All of us at PHI Learning are glad that our book, Software Design, Architecture and Engineering by Dr. Bhatt, is going to release today. And we do hope that the students will be immensely benefited from this textbook. On behalf of PHI Learning, I express my heartfelt thanks to our guest of honor and speaker, Professor C.R. Muthukrishnan, former Deputy Director and CSE Professor IIT Madras, who spared time from his busy schedule to release our book. I'm grateful to Dr. Bhatt, who gave his vital time to grace this book launch event. I'm very much thankful to Dr. Bhatt for his long-term association with PHI Learning. I consider myself fortunate to have the opportunity to work with him on the textbooks authored by him. I also want to extend my sincere thanks to Mr. H.R. Mohan, Chair, ACM Chennai, and Chair Special Events IEEE CS Madras, Dr. P. Sakthivel, Chair IEEE CS Madras, Dr. Priya Vijay, Chair CSI Chennai, and their team members. Without you all, this book launch would not have been possible. I'm also grateful to all the participants for attending today's book launch event. Thank you once again to all of you. Stay safe, stay well, stay inspired. So with that, we will go ahead with our book release function. Over to you, Mr. Mohan.
Thank you, Ms. Shivani. Before we go ahead with the formal launch, we would like to acknowledge the presence of our senior members from CSA and IEEE, Professor Rajaraman, Dr. Surendra Kapoor, Professor Vishwakarma, Dr. Subbaraj, Mr. Nandakumar, Dr. Om Vikas, Professor Sankaran, and also the Chairman and Managing Director of PHI Learning, Ashok Ghosh. Thank you for joining with us in this evening program. Now I would like to request Professor Muthukrishnan to formally launch the book, The Software Design, Architecture and Engineering, authored by Professor Chandra Bhatt.
Thank you. On behalf of all of us here, I'm very happy to launch the book by displaying it on the screen. Thank you very much. Professor Bhatt and I have been colleagues at IIT Kanpur.
Sir, can you show it once again, sir? Can you show the book once again? And your face is not visible.
Yes.
And maybe you can take it on the right side, please.
Okay.
Yes, that is fine, sir. Shivani is missing. Shivani is missing. Professor
Yes.
is also missing.
I know a virtual program requires a lot of fine tuning.
Okay. Right. Thank you, Professor.
Thank you very much.
Thank you.
Professor Bhatt and I have been colleagues at IIT Kanpur, and later he headed the Department of Computer Science Engineering at IIT Delhi. We have been in touch. In fact, I wrote a preface for his book on operating systems, concepts, and practice, which got published when he was in IIIT, I think. I'm very happy to be part of this program and wish all of you, the professionals, faculty, students, and others, a good time with this book, and I hope everyone will find it useful and interesting. I have a talk to give, and I don't want to preempt what Professor Bhatt has to say about the book and so on, how we came up with the concept and the thinking behind how the book is structured. It is wonderfully structured. It's got 8 chapters. He will talk more about it. But I will sort of give a broad brush sweep of the field of software engineering. You can title it as one man's view of software engineering because the field is so rapidly developed and still continuing to develop. And also that it's a field which has brought many professionals from industry, academia, research labs, and so on into play. And but this is one field where probably the presence of young people, I would say, in the 20s and early 30s and so on, is a very large number. Large number of people are engaged in these activities. It has been a field with many challenges to which researchers, developers have responded quite well. I'll be touching upon a few of this briefly in the talk. It's a difficult proposition to give this talk, especially in about 30 minutes or so, partly because if I give you a helicopter view or maybe even a 30,000 feet jet view, we won't be able to appreciate the details. On the other hand, if I make it a walkthrough, you will see some details, but you will not get the big picture. So I have to be somewhere in between. So to guide me, I have made a set of slides. It's more a guide to me, and as I walk through the slides, I'll be bringing out some aspects of my own experience in growing up in this field. So can I have the presentation, please? Akila, can you put up the presentation? The PPT or PPTX. Thank you. Is it showing on all the screens? I'm not seeing it yet. Or I can present it from my end.
No. Yeah, I think.
Yeah, I think I'm able to see it, but you have to select the window, I think.
We can all see.
You're able to see? Okay, fine.
Yes,
We are able to see. We are able to
Yes.
see.
Okay, I have my copy, so I can go ahead. Yeah. So once again, very happy to release this book, Software Design, Architecture and Engineering, Concepts and Practice, by our respected and admired colleague, Professor Pramod Chandra Bhatt, published by Prentisol India Learning Private Limited. And also I thank at the outset, Computer Society of India Chennai chapter, ACM Chennai professional chapter, and IEEE, sorry, the I is missing, IEEE Computer Society Madras chapter, Mr. Mohan and all the office bearers of these professional societies and so on. Next one, please. Can you advance the slide?
Yes, it is advanced.
Yeah, it has moved.
Okay. So I've sort of taken the theme software engineering 1960-2020. That's a span of 60 years. Prior to 60, we had Fortran, of course, and we had assembly languages, and most of the operating systems were developed in assembly language. Somewhere in the mid-60s, early 70s, some interesting developments took place. COBOL had come about in 61, and then this IBM came up with this panacea for everything kind of language, PL1 and so on. But we are now in 2020. It's a big span. 60 years in the Hindu calendar has a significant cycle. Okay? In fact, our convention of naming years repeats every 60 years. The term software engineering itself got coined in 1968. I think it was a conference a NATO conference in Varnish. And somewhere around that time, or maybe a little later, a significant book appeared called Mythical Manments by Frederick Booth. The background to this was a bold venture by IBM at that time, along with the 360 mainframe machines, full range of models and so on, called TSS 360 or something like that. It was a very ambitious project, and the project failed. They did not deliver the system. And what I've heard is that they had something like about 2,000 people working on that project for a couple of years, somewhere in one location or in multiple locations in the US. Those days it must have been in one location, I think. And Fred Brooks, I think, was one of the managers in that. He later went to teach at North Carolina. He basically made the point that putting more people into a software project is not the solution. And we need to address the basic issues and so on. I would like to draw quickly an analogy with civil engineering, which is a very established field for several hundred years, maybe 300, 400 years. In fact, civil engineering as a practice, we have known even over centuries, I would say, several centuries. We have our own temples and monuments and so on. But civil engineering in the modern context of infrastructure and townships and so on, I think we can say about 300 years. But if you look at the field, there is an architecture, civil engineering, and construction management. These are completely different programs in terms of education, preparation, professions, and so on. Though they do interact and overlap. But I don't think we have reached that kind of a maturity level in the field of software engineering, though, of course, we have really traveled much distance in terms of progress in the 60 years. It's interesting to note that software was bundled with hardware in the early decades, even up till, I would say, late 60s and early 70s. Software was not priced. Nobody paid for software. It was paid along with hardware. Of course, it did cost to produce software. System software was mostly in assembly language, and application software was mainly in Fortran and COBOL. This is circa 1960. Next slide, please. Okay, in 2020, the IT industry globally is about 5 trillion or so. Huge number. In fact, the Indian economy is aiming to become 5 trillion in about 2 or 3 years. Though, of course, I think with the pandemic, the challenge has become somewhat disproportionately aggressive. Of course, this 5.2 trillion I've taken from the web, not a very reliable figure. And also the figures say there are over 21 million software developers, and there is still skill shortage. So you can see the immensity of the field in terms of its impact on society, economy, other segments of economy, and so on. In fact, the buzzword is that Industry 4.0, Education 4.0, and so on. This explosive growth is fueled by synergy of several technology developments over decades. In fact, Professor Rajaraman has recently come out with a wonderful book on impactful technologies. I think cutting technology, I don't get the correct title immediately. Broadly in the field of computers and communications. And many of us, including me, have been co-travelers during this intensive development. And it is not abating. I think we have probably several more decades of such rapid growth and development. What is a major driver behind all the software effort? Productivity and getting it right. Productivity is how to do it efficiently in terms of resources, including time, people, technology, and so on. And getting it right, I put it in quotes, right would focus on function, performance, user-friendliness, security, fewer, no more glitches, and so on. It could be a very long list of things to focus on. However, they have to be prioritized and given emphasis. Next slide, please. So I have restated it in some simple terms. Safety from bugs, correctness, correct behavior right now, and also defensiveness, correct behavior in future. Because particularly much of the software now is open to access and modification by several sources, and therefore defensiveness is also very important. Easy to understand. I think this has been understood from early on itself, that programs have to be read by people and worked upon. Software has to be adapted, evolved, and worked upon by people, and so on. Then it should be ready for change. It should be suitable so that you could adapt it for suitably for the changes that come from the external world where it is working, and make it suited for changes. So there are many other important properties, even though I've listed 3: performance, usability, and so on. But they can all be captured under one of these 3 headings in some manner. Next slide, please. Okay, so when you look at a software system, we also have to consider the total system, including the environment. Software is only one part of the of a bigger picture. It's like, between an aircraft and a airline company or a flight service. Just to give a very crude analogy, we also have in the software field the concept of project, to plan, design, execute, roll out, maintain, and so on, development, deployment, and so on. And it gets further broken down into requirements, design, what have you. So there is a process to run the project, and also the project can span the life cycle. And also there's a product concept. Software is a product, so that, the product concept is very seminal underpinning of engineering. The other aspect of software is that complexity. There are several dimensions to it, not just merely scale. Even an app in a mobile can be fairly complex in terms of what permissions it wants, what permissions it asks for, and so on, so on. Scale, system of interconnecting, interworking parts with structure. So it's a very dynamic situation. And we can view this entire big picture in terms of architecture, models, and design patterns. And life cycle is important for software. Maybe as we move on to the next slide, I'll quote a few examples of successful software that we have developed in our country. Of course, Dr. Ramani is here, who has been in the NCST and later with HP and so on. I think the first one I can recollect is the Impress. That is the railway reservation system. It was a high-impact system at the time it was introduced. It was developed by CMC at that time, Computer Maintenance Corporation, later just called CMC Limited, later taken over by Tatas and so on. And then, of course, more recently, we have the Aadhaar project that's been successfully rolled out. It's an ongoing thing. And then we have the passport seva and so on. Several areas have been touched. Several areas of common man's life have been touched. And I think, though this is because of the synergy of several technologies coming together in an integrated manner, software is a significant, important component of this. There are several. I've just mentioned only a few. The next one. So, software is, and most of the development in software is driven by abstractions. We want to keep details hidden away to some extent, but we would like to have some clean, well-defined interfaces so that the whole thing can be used. A good analogy here would be a VLSI chip. There are many people who work with integrated circuit chips, but they don't go into the circuit details. They do look at it in terms of the interface pins, where do you put power, how do you clock it, how do you connect it with other chips, and so on and so on. Okay, so this kind of abstraction is very important. Many examples can be given. So some examples relevant in the field of software I mentioned briefly here. The abstractions can be viewed in the dimension of resources. So storage, if you take as a resource, or persistent store like disks and so on, you can say database is an abstraction. Earlier it used to be files and so on. Process is an abstraction. Threads are an abstraction and so on. These are mainly at the level of an operating system and things like that. Then abstraction over a network and the internet, these are things like clouds and so on. Then we move into the abstractions relevant to constructing the application level software. I broadly position my talk here in terms of infrastructure software and application software, though it doesn't that easily divide into a binary description of space. The infrastructure software would be things like operating systems and database management and so on, server-side software and things like that. And application software, again, is a whole host of it. And I think there are developments taking place in both of these in terms of progress. Then we have the object-oriented paradigm, which has made very significant influence. In fact, Professor Bhatt quotes in his book, David Parnas, who was one of the early authors. He was a kind of pessimist, he wrote a paper in, I think, 1974 or something like that, where he pointed out the need to structure software into modules, and he gave out some interesting properties of modules. Just like they should interact only at the interface connections and not otherwise, and so on, coupling, cohesion, what have you. Then we also have models like data flow and workflow. So some of these abstractions also model the in a generic manner the application space, the enterprise or the organization where the application gets going. All right. Of course, we do have when we go into the design level, we have hierarchical structures, layered tree structures, interaction-oriented message passing structures, or shared memories, and so on. And virtualization and containers have been some very important ideas which have driven much of software development, both in terms of infrastructure and also in terms of certain application level things. Containers are also great. Next one. Okay, I'm continuing with some more abstractions. We move from, the mainframe kind of technology, and they're not very relevant. They're still continuing. Legacy systems are not going to go away that soon. But I think in terms of a very large percentage of the 5.2 trillion that I mentioned, I think it's coming in terms of distributed systems. MapReduce is a great invention. 2004 it started. In fact, all these new companies which are impacting in several dimensions, enterprises, governments, public people, and so on, like social networking and mail services, cloud services, and so on. They all use. All these companies use the infrastructure on which they run is not a single computer, it's not a mainframe computer. In fact, it is commodity computers, but in very large numbers, and of course, even geographically separated and so on, and which form the backbone and the connection between them, especially even the connection over the internet. The internet has been advanced by MapReduce. Component is a very interesting idea. Much of this results in good productivity because of reuse. There's a simple saying, giants stand on the shoulders of each other. And I think, all these things make reuse possible. earlier it used to be only libraries and so on, simple code structure, then includes and stuff like that. But now you can do a whole lot of well-defined components and so on. Then this model view controller is a very important abstraction. It's impacted embedded systems in a significant manner. So the model here talks about the model of the system where the computer is embedded. View is a dashboard, and controller, of course, is what you give back to the system. So if you look at, for example, a digitally empowered automobile, fancy thing will be driverless cars and things like that, what have you. You can abstract it in terms of model view controller at the high levels and so on. Then service-oriented architectures, you look at the resources from which you build, not as codes and so on, but you look in terms of services offered and also microservices and so on. This has given rise to a whole lot of technology, which I put as XaaS, something as a service. Okay, web apps, of course, progressive web apps and so on, and user models. What kind of users do we have? Are they naive users, power users, and so on? In fact, one of the very heavily used operating systems, Linux, earlier Unix and so on, did not go well with user because it had the teletype or it had the terminal interface, character-oriented interfaces. Later, of course, with the advent of Smalltalk, which also Professor Bhatt mentions as one of the early developments of an object-oriented platform, which was later taken by Xerox and so on, and then Microsoft. I think now, and the bitmap display, so many different technologies coming together have made visual user models very convenient at all levels. In fact, if you look at, as an example, just the finance sector, all these high-strung, nervous guys sitting in terms of looking at dashboards to work the stock market or the equity markets and so on. They all have very rich visual interfaces and things like that. So the user models are very important. Okay, I'll digress a little bit at this stage. I hope I'm keeping time. Someone can give me a 5-minute signal so that I don't eat into the time of Professor Bhatt and monopolize it. So I want to digress a little bit and look at how programming is taught and learned. It is still, to a considerable extent, unsatisfactory. Of course, I think nowadays programming is taught and learned at several different levels, right from school, CBSE has it, and then of course all first-year courses have it, and even other professions probably have it in terms of some tools they use and so on, things like that. But if you look at programming, the first programming exposure, we learn natural language, kids learn natural language, and then maybe mother tongue, English, whatever it is. And then they come up to a certain level of fluency and merge it, integrate it with whatever they're engaged in, profession and so on. Now, can programming come into that kind of a position? Programming is a broad thing, not necessarily in terms of a programming language, but programmed artifacts. In fact, early programming used to be by connecting wires and things like that. We have come a long way. Now, the way it's taught is hit and try versus engineering. So it is not taught as an engineering subject, it's taught as a craft. In fact, if you look at some of the titles of the books on programming, early books, it used to be called Craft of Programming, Art of Programming, Discipline of Programming, then Science of Programming. And then there are also titles like Programming for Poets, Programming for Lazy People, and so on and so on. Very interesting, because these were very early books. The emphasis is exclusively on correctness, and only and exclusively on correctness. Get a program right, given an input-output relationship, does it produce output for the given inputs? We don't venture beyond that. So that approach is sort of based on unbridled optimism, or what I would call irrational exuberance, to quote Greenspan's quote on stock markets. And no reading of good code is done in any programming course. everybody writes programs, but nobody reads. On the other hand, look at how people develop fluency with other communication. Well, programming is for communicating with machines, right? And with people also. How people develop ability in other languages, they read good stuff, right? But all this is now possible thanks to technology. And I'm making a sort of provocative observation here. There would be some leading schools where this is done very well, but I think this has to spread in a much wider sense. Because I think any software engineering has to start with a good programming, learning of good programming. In fact, many curricula after some courses in programming, followed by the first course, maybe Java, whatever it is, data structures, blah blah, they go into a software engineering course directly. Okay. So another slide on that. Writing code before testing any of it. This is very commonly done. In fact, something like 25 years ago, there was this thing called Turbo C, which was developed by UCSD Pascal, University of California at San Diego. They came up with a certain, you can say, a platform kind of thing, a workbench, you can say, so that even though it was toy, it was not real life. So student would do something called a project. Every program would be a project, and if you use all the facilities, you could keep the test cases, everything, and so on. But very soon it was given away. It was cast away, partly because it was not connecting with real life. But now there is some good stuff that one can use. I'll mention it briefly a little bit later. Then keeping all the details in one set, assuming it will be remembered forever and not putting it in your code. This is another. So whenever we teach programming and evaluate programs on whatever dimension of plane it is, code, pseudocode, whatever it is, do we give emphasis? What are the rubrics we use? What is the emphasis we give? Do we look at the quality of the code over and above, in addition to the uncompromising requirement of correctness of output? Software engineers are pessimists. They write, good people write little bit of code at a time, testing as they go, and they document the assumption that the code depends on. So these are some simple things, but I thought I should draw attention to this in this talk. Okay, then we look at little bit on software tools. Are you advancing the slide? I am on 10 now. Okay, software tools. There are many lifecycle tools, requirements, specifications, use cases, ER diagrams, test tools, test generators. And very interestingly, recently, there are some formal methods and tools based on formal methods, verification and model checking. Verification was considered very theoretical, abstruse mathematics, theorem proving, and so on, but they actually come into the practical domain. In fact, companies like Microsoft have invested quite heavily, and some of the critical parts of the code, especially in the infrastructure code, are put through model checking. Model checking is different from testing. Testing is to expose bugs and fix them. Whereas model checking is to establish properties of code and so on. And this is not taught in the education segment very much, though of course in the research segment it may be taught and so on. In fact, I know very few institutions outside industry where such tools are actually available, but some are available. For example, Professor Nori developed some tools on these lines for transformation of code, safe transformation of codes in TRDDC and so on. Now we have code bases like GitHub. I've mentioned several others, OpenStack and so on. GitHub is an excellent resource. It is so good that Microsoft decided to take it as purchased it, and they're supporting it. It is an open source. It's very, very interesting. It's a code base on which one can build. Okay. And going to process, there are also development process models that have happened. Professor Bhatt's book mentions all of these: agile, DevOps, pair programming, and so on. I'll touch upon a few of these, not in detail, but draw attention to some interesting stuff about this as we go along. Okay, now I will go to the final part of my talk. A few exciting, cutting edge. What is happening? All right, what is happening now? Okay, so I have selected four things. I've mentioned only three in the slide. One is, one I'm going to steal it in, though I have no slide. It's not on my slides. One is low code, no code solutions. All right, it's a very catchy jargon. Then another one is called spreadsheet being enhanced with what is called Excel, of course, Microsoft Excel. Plus, I'm sure others also would have been working on this. Lambda, called Lambda. It's very interesting. Lambda actually comes from Alonzo Church's work in mid-30s, 1937 or 38, even before Turing's work. And of course, before short program computer, which is familiar to von Neumann and so on. And it's very interesting that this has been now reinvented or repositioned into spreadsheets. There used to be a theoretical result that spreadsheets are Turing incomplete. They cannot do all computation. There is a concept of Turing completeness. Everything computable can be computed with some reasonable assumptions and so on. It's interesting that Microsoft is actually releasing a product. I think right now it is in a, beta version or whatever you call that, insider version, called Excel Lambda, where you can put into Excel what looks like functions in C and things like that, but without disturbing the basic engine of Excel. See, spreadsheets you don't do any programming, but you can give formulas and the whole thing will settle down to an equilibrium, right? If you change something, the entire thing gets recalculated and so on. So you define everything. It's mostly declarative in terms of formulas and everything, connections between variables and so on. And then the whole thing settles down. And spreadsheets have got enormous application. The first one, Lotus, did survive in the market, but I think Excel, do you know of any finance person who does not use spreadsheet? they will simply, collapse without it. So, of course, user spreadsheets has created another problem in organization of lack of data discipline. In fact, I consulted for IDBI where this was a major challenge. I think at that time, Mr. McKerney was the, CEO or something like that, IDBI. That was probably in, close to 1999X or 2000, something like that. Okay, then quantum computers. It's still exciting. It's still a research area, but it is it's coming closer. 25, 30 years ago, Gartner said that it will be another 3 decades before quantum computers will see some daylight. And I think that projection is coming through. Many of the visionary projections are coming through in their own way. For example, I attended a talk which I mentioned in other places also, where I think Robert Fano was in IIT Kanpur. I don't remember. They had this thing called Project Mac after the failure of IBM, Multics and so on. So he envisioned the following. He said that just like electric utility, we will connect to an outlet in the wall and we'll have information from the world at our tips, both for using and for interaction. It is a dream. And I heard this talk probably in late 60s or early 70s. I think late 60s, if I'm right. And at that time, these visionaries foresaw so many things, The memory cost used to be spoken in terms of how many cents per bit or how many microcents per bit and so on. And it was all core threaded memory. Nobody had semiconductor memory, and now we have got SSDs and all kinds of technologies. So I will talk a little bit about quantum computers and programming quantum computers. In fact, if you go to Amazon and Amazon website for sales, for commerce, and type books on quantum computer programming and so on, you will see some books there. They're very expensive. Each one is selling for something like $7,000-8,000 and more in Indian rupees. Even some of them, even in terms of dollars, are selling for probably $1,200 or something like that. So hot area. There are people working on it. Okay, first about low-code, no-code platform. This is actually derived from rapid application development. Some of you might have heard of this thing called robotic process automation, RPA, right? So you can say it's a development model to develop an application rapidly by observation. For example, you look at let us say a call service operator. He's looking at some screens. He's taking some inputs from a customer, and he's doing some manipulating the screen and giving some responses. If you capture this entire script and later and not just one script but several scripts, and then classify them and group them and so on into scenarios and so on, then you could go from that to some kind of script based application and things like that. So uh, of course these are most of them are driven by diagrams, and uh, those who use these tools are required to understand the business apps and their development environments. So they have to be domain-rich people, savvy with how to deploy technology at a higher level in their domains. And so I think, some of this is really getting attention now. Because, no company wants to, no big organization wants to give or to take I will do everything for you kind of approach. I think this idea is there in many other professions also. For example, uh, do you want to go to your doctor for everything? There's also of course, you don't want to self-medicate, but I think, one has to have some understanding of some of the health issues and so on, things like that. Okay, now a little bit about Lambda from Microsoft. I'm giving you two references here. There's a YouTube where this is explained, YouTube video, and there's also this. The second link in this slide is if you click it, you'll go to the announcing Lambda website of Microsoft. Okay. I don't think I have time to do this. There are interesting examples and so on, so I'm not going to take your time. But it's very interesting to delve into this and see where one can go from this. In fact, I think these kinds of things very soon, in fact, sooner than later, I would say, because I think we have to bring it into the skill and education space for people in other verticals like finance, accounts, and so on. Okay, a little bit about quantum computer challenges. The promise of quantum computing was first recognized in the 1980s. Like many things, I think this there have been very early recognition, early stalwarts, pioneers who have recognized the potential of these things. Of course, quantum mechanics is a very intriguing subject. It's a subject in physics. Many very renowned physicists are associated with it. One of them being Schrodinger and several others. But to sort of, for our context here, even though I'm not a specialist, I would venture into sharing a little bit with you. We know about action at a distance. We learn it in school, right? Two masses separated by a distance attract each other. The force is m1 into m2 by v squared, right? So this underlies, we learn it in atomic spaces, in the structure of atoms. We also learn it in the planetary system and so on. Okay, but the quantum phenomena originally came in the atomic and subatomic. That is where this was proposed, to understand better in greater detail and be able to harness what happens in the atomic and subatomic levels and so on. But interestingly, it was discovered that this also happens in the macro, in the universe. So the quantum phenomena, the way it has traveled over the, you can say several decades, particularly these 60 years, I would say, from 1960 to 2020, is that it's sort of straddling both the very small and the very large, extremely large. Okay, but of course we are focusing on the extremely small, the quantum, to make the quantum computers and so on. What are the challenges in this? I think the basic idea is that there's something called qubit, which is different from a bit. Bit has 0 or 1 as a value. A qubit can be in either, it can be in one of the states, but with a probability and so on. Okay, and they're entangled. That means qubits interact with each other. It is this interaction that we use to change state. You can look at any computation, even in our traditional computer, as a large number of bits, which the state of which the values of which is being manipulated by operations through programs and so on. In the quantum computer, these are qubits, and the entanglement of the interaction between them is what changes the state and so on. The challenge is that this state change has to be in a very controlled way to get useful computation. And that can happen only in a very small, for a small amount of time. If we allow the state changes through entanglement between qubits to go beyond a certain level, noise and other coherence and other so on come into play. It's more or less like how communication channels, as we know, were very unreliable and how we had to struggle to make them more reliable and so on. To give you a crude analogy, that's the kind of challenge in quantum computing. However, even though we don't have really working quantum computers deployed, though they're there in the research and so on, and there are simulators and so on, but people have addressed the issue of how to program these quantum computers, what kind of problems, and how to describe a quantum algorithm, what will be the primitives, what kind of operations we need in order to manipulate qubits and so on. Okay, so that's what I mentioned in this slide. The loss of coherence or decoherence caused by vibrations, temperature fluctuations, electromagnetic waves, and other interactions destroys quantum properties of computer. This is understandable. You see, to digress again a little bit, Einstein gave us this equation E is equal to mc squared. Most of us understand it as mass can be converted into energy, right? And the amount of energy produced is the mass multiplied by the square of the velocity or speed of light. However, it can be used in the other way. Any equation, there's no partiality between the left and the right, right? I'm talking not the assignment in programming, but the equation in mathematics and physics. Okay, so it's possible to convert energy into mass. And it happens. Where does it happen? It happens in particle accelerators. Some of you might have heard about CERN, the Garg particle, and the physics community, research community, experimental community, setting up something in Kolar deep under the surface of the Earth to detect a particle and so on, right? So these particle accelerators actually push a lot of energy, and this energy has to accelerate. That's why they're called accelerator. And finally, after literally several, I don't know, hundreds of kilometers of travel and transit, maybe even more, I don't know, I may be missing an order of magnitude there, those particles emerge. All right, so the equation works both ways. That's a digression. So a breakthrough is probably several years away. In the meantime, how do we get useful results out of a computer that becomes unusably unreliable before completing a typical computation? Okay, I'm coming to the end. So programming quantum computers, again, I'm giving two interesting references. Microsoft has a quantum development kit, including what it calls Q-sharp compilers and simulators. IBM has got something called QIS kit. Again, there's a YouTube video on that. Then something called Silk, which is very interesting. They're looking at a higher level, quote unquote, higher level programming of quantum computers, so that they are envisaging some way of converting, maybe to start with hand conversion, to something that can actually run on a quantum computer. All right. So software engineering is traveling a long way. So how do I sum this up? The field of software design, development, engineering has seen much progress, unimaginably vibrant progress in the last 60 years. The field is very vibrant and accelerating, both in terms of research and practice. Thank you very much for giving the time. It's an honor. It's a special honor for me that I've had Professor Rajaraman. Mrs. Rajaraman and Professor Ramani also in my talk, and of course, Professor Bhatt. Thank you all very much. I'm now handing over to the organizer.
Thank you, Professor C.R.M. for your excellent overview presentation, giving the both historical as well as futuristic position of software engineering. Thank you very much. Now may I request Professor Pramod Chandra Bhatt to present his aim as well as motivation in writing this encyclopedic book, which covers almost all the topics in software engineering from the inception and also touches on futuristic software design aspect. Over to Professor Bhatt.
Well, thank you, Dr. Mohan, and of course, I'm glad that Professor Rajaraman Ramani and several other well-known computer professionals are attending this one. I should like to begin. Can you please go to the next file? Please go to the next file. Yeah. You know, I must admit that there was a period when I was a pure academic, and then once I finished my academic career, I just thought that I should recycle myself. And in my second life, I became a full-time software consultant. I operated a company which I called as Vijay Software Solutions. You see the image of the ducklings. They are actually the replica of the kind of image that I carried from my visits in Germany, in the lake near Heinz-Nixdorf Institute in Paderborn. The ducks used to, as a family, swim around, and VSS is essentially the kind of natural extension of that imagination that I had. Anyway, the reason why I formed the company and felt the need for it was because as a full-time consultant, I figured out that in the industry, there's a lot of adhocism. And my colleagues who may be listening from industry might take it with a pinch of salt, but then I thought that it's very important to inculcate a degree of systemic thinking. The other thing that I feel a lot of adhocism leads to just some decisions which do not necessarily lead to a good program development environment. I personally think right from the younger age, right from the days when students learn programming, it is important to emphasize to write programs which are correct by construction. It is very, very important in my view to inculcate that habit that when you write a program, there has to be a plan, and that plan ought to be such that it leads to the objective you have set for yourself. I think this applies to program development as well as to the software development. I wound up my company because I decided to really retire and move to a senior citizen home in 2018. So I just wound up the company. May I have the next slide, please? Now, in my view, a person is a good software professional, when he understands the underlying design considerations. And design considerations include the kind of programming language that has been used, its strengths, limitations, and so on. To just give you a sense of it, are you using a C++? And if you're using a C++, are you using the capabilities that are offered by C++? Or if you're using Java, are you using packages? Are you able to create packages? Are you able to take the advantage of the libraries and so on and so forth? One of the things that I found is that the software models that you may use ought to be primarily addressed to the use scenarios. Quite often, the use scenario may be the reason for the development of a particular software, but you may make some assumptions. And I think Professor Muthukrishnan pointed out about the underlying assumptions. For instance, we are all aware of the Y2K problem, which of course has had its own underlying assumptions and it kind of opportunities it may have created for India, but it also was a nightmare for many software people in the industry. My sense is that it is important for people to have an understanding of an architectural pattern which would deliver the needs that need to be met for the user scenario. So it's very important to have an overall understanding of the software architecture as a discipline and as a mechanism to be able to deliver the kind of specifications or the requirements which the end user is likely to be encountering. Finally, I should also emphasize that it's very important to be able to deliver a product in a manner that the product actually not only has a certain life cycle, but also is very reliable. Its quality is guaranteed to an extent, and its reliability of the reliability of the package or the product is ensured. Next file, please. So as a full-time consultant, when I was interacting with people at different levels, what I found was that not much attention is being paid to the design methodologies. In fact, even though, of course, Professor Muthukrishnan mentioned about the spreadsheet in its new avatar, I might mention that the spreadsheet as it is used in present avatar is often man management and job assignment. And managers in the industry have, in my view, completely stopped reading new literature or new or adapt to the new methodologies, and they are completely oblivious to the kind of software architectures and software practices. I'm sure some of you may not like my such frank and open criticism of a lot of people in the industry, but I have seen it, firsthand, and I find that it is very important that managers understand what is deliverable and how it may be delivered. In other words, the strategy that would lead to final delivery. That's where they ought to be addressing themselves and get their programmers to write programs accordingly. I also find, and I think N.R. Narayan Murthy at one point in time mentioned that most of our graduates are unemployable. And they are unemployable. This is because the students have developed a mentality of what I call as a user manual mindset. User manual mindset, by that I mean instead of thinking in programming terms, in design terms, and so on, they think in terms of being able to just write something and submit or get on with it and then move on. They have very little, understanding of the software, what software modeling or software design considerations. In my view, it is very important that an attitude is developed at the time when the student is learning to program, that there is a holistic thinking that ought to go behind modeling this particular software that one is developing. Next file, please. So the objective I set myself for this book were to help the undergraduates understand the concepts underlying the software design much better than what currently because they are driven by the user manual mindset. I would like to see the undergraduates move away from that kind of a mindset and move into a mindset where they address themselves and apply their mind for the foundational understanding of software design. I would also like to see that IT professionals aim at becoming thinking architects. By that I mean that they ought to, as I said, apply their mind to architect the system in a manner that users' aspirations are met, and they should be following the best practices of software engineering to keep the costs down and also to be able to give or deliver the product within the time frame that is expected. So what I have done is in the book, I offered a lot of references to dive deep because it's not possible to cover everything within a compact book of something like less than 300 pages and also cover everything. So I've given a lot of references for any detailed understanding that one may wish to move to. I also have added a section which is called points to ponder. Now, the idea of this points to ponder as a small section in at the end of every chapter is to create a consciousness to be able to think deeper and actually think imaginatively. In in my view, it is very important that people think beyond what they read just in a particular chapter and then apply the particular solutions for the kind of problem and use scenarios that they may encounter. So shall we move on to the next file, please? Now, the book structure, there were a few considerations. As I said, I was very particular about emphasizing the foundational aspects. And that's where, in my view, again, I would say that discrete math and computer science, concepts like completeness, consistency, object relationships are very important and these need to be understood. In fact, in the book, you will find that there's a very large number of examples. They have been taken from the real world scenarios, from the kind of things that I experienced as a consultant, and I often quoted that. I also believe that David Parnas, when he mentioned about separation of concerns, I think he hit right on the nail. That is, in my view, the most important principle of design. The examples that I have taken from the field actually cover sales order processing, the electronic design automation, graphic systems, networking, and so on and so forth. I have also tried to cover certain aspects or the process of the software development, particularly in the context of large systems. Large systems actually require a considerable amount of brainstorming. And I think Professor Muthukrishnan actually mentioned about write a little bit of a program and then test it and make sure that you're doing it right. In fact, there's a discipline within the software engineering which is called test-driven development. And the book actually covers the TDD or the test-driven development as a part of the protocol within the agile systems. One other aspect which I have emphasized and I wanted to really have the attention drawn to are the architectural patterns. In fact, it's very important that every architectural pattern is understood deeply to figure out what may be the pros and what may be the cons. So as we go along, I think I will probably mention a little more as in the next few files. So shall we move on to the next file, please? Next file, please. Yeah. Let me now dwell upon the chapters in the book. The first chapter, of course, is very simple. It's emphasizing the O thinking, and the point that I wish to emphasize primarily is that O thinking is achievable through the high-level languages. I do mention about the software modeling and the patterns of software architecture in chapter 1, but more detail in a separate chapter, which is chapter 7 in the book. I also talk about the primary principle which ought to be adhered to for software design, which is the separation of concerns. And insofar as engineering practices are concerned, I emphasize agility and talk about the test-driven development. The chapter 1 also has a brief indication of the case studies. So let me just go through the chapters now in sequence. So shall we move to chapter 2? Yeah. My sense is that very few people actually truly understand the notion of an object. I figured out in the industry that most people think that just learning to program and use C++ means they know the object orientation. That actually is not true. What you need to comprehend is that no matter what form or what is the structure that you may actually be contemplating uh, for the data, what is its context? And in that context, what is its meaning? It's very important that the context and the semantics of the data is very well understood before you move on to doing data structuring and then developing a particular software. Another important thing is that every domain will have a set of data, and there will be these data which actually have one or the other form of relationship amongst them. And we need to be able to understand the relationships which are embedded in the data for us to be able to see how best we can use the data operations for getting the kind of solutions that we are looking at. So the next important thing then becomes is the nature of the data operations. And of course, the particular chapter moves on from the data definitions, data operations, data types to abstract data types. I think Professor Muthukrishnan in his address also mentioned about the abstraction. So what is the level of abstraction that we ought to be addressing or taking forward in the design? Once we add inheritance to the data, there are a lot of advantages we derive. And that is where essentially the object orientation kicks in. So from the point of view of object orientation, it is very important to understand the notion of the state, the behavior, and the manner in which the object characterization can be used in a particular use context. Next file, please. I think I'm running out of time. 7:30 is when you said the session will be over, so I probably will have to rush through a little faster. One of the considerations which I had was to try and indicate how the programming languages actually evolved. So I have gone through a considerable amount of background preparation in bringing out the notion of high-level languages and why it is important to bear in mind that when you design a high-level language, it is important that it is Turing complete, or at least in the sense of within the considerations of limited word length, you are able to offer a notion of Turing completeness. In fact, the paradigms that have been used in the past, for instance, the functional programming or the logic programming, and subsequently the object-oriented programming, in certain ways all aim to offer a degree of completeness. The degree of completeness actually ensures the extent of your ability to be able to solve problems. I do emphasize the kind of program structures, modularity, and one of the features I've added in this particular book, which I think not many books mention, is the nature of the metric that need to be used when you're doing an object-oriented design. When you're doing an object-oriented design, there is a certain extent of orthogonality that you need to observe in the definition of classes, so that you have minimum number of classes to be able to spawn as the entire gamut of things that you wish to have. However, they should. It also impacts a degree of reliability in regards to the implementation. If you have overlapping classes, you will have excesses and usage of methods which are sometimes from one or the other class, and that can create conflicts. Anyway, the chapter has an appendix on Turing completeness and also has some examples, particularly emphasizing the polymorphism, inheritance, and such other characteristics in the object-oriented context. I may also mention, since I'm on the programming languages, that when you use a high-level language, C++ offers you a degree of object orientation. Python goes a little bit beyond, and Pythonic thinking requires that your level of abstraction of objects is very different from that you do in C++. Time permitting, maybe if there's a question or something that I may even explain that in a little more detail. Shall we move on to the next point? Next, I indicate that it is very important to move to visual programming environment. Professor Muthukrishnan already mentioned about the IDEs in some ways. And in fact, one of the things that I may mention is, for instance, the use of Scratch for development of prototypes. In fact, in the book, I emphasize that tools of this nature which actually help in high level of abstraction to be able to indicate through a rapidly developed model to give a particular system's behavior is very important. And that is what you should be able to do using something like Scratch. I also talk about Anaconda and the Python with particular examples on the data analytics, so that you get a sense of visual program development in its every facet. Next file, please. I talk about agility in great detail in the book. In fact, it has a fairly detailed description of the agile methodology. There's a running example which one carries through, and the other thing that I've emphasized in it is the nature of testing that needs to be done at every incremental release that you may make. So the importance of agility lies in being able to offer incremental releases and also ensuring that there is a correct interface. And each time you have a next release happening, you should be able to completely explain to the following release, for the following release, the interface. In fact, there is a metric that I have defined and explained in the book for agile development that you would see in more detail in the book. The concepts which are like time boxing, sprint, and scrum with the role definitions have also been covered in this particular chapter. Next file, please. One of the things that I've emphasized is requirements engineering and UML. UML, with all its 14 important diagrams, has been described in its great detail, and something which is a little more related to my own field of research at one point in time, which is petri nets and morphic nets. Morphic nets are, in some ways, modified petri nets with added semantics to it, which is more data-oriented semantics. And I think one will have to take a deep dive into the book to really comprehend as to why morphic nets raise the level of, or rather modeling level or modeling capability from petri nets to closer to Turing compatibility. Next file, please. I also have talked about the, I've exceeded about 5 minutes now already. I also talked about the software modeling and architecture. I've talked about these in the context of the use of the separation of concerns, identification of the application program interfaces, APIs, I also talked about client server and the middleware. This is more in the nature of what I noticed when I was consulting for IT companies, that enterprise systems do use extensively the middleware, and it is a key component, it is a key part of the entire systems architecture. I also indicated in the book the type of quality attributes that are important for the to be able to evaluate an architecture. As to, you may recall that in early part of my talk I mentioned about being able to say a particular architecture would probably be more beneficial in a particular use scenario. So it should be possible to have a degree of evaluation for any particular architectural pattern. So there are several architectural patterns that have been described in the book. Then, of course, I also indicated the manner in which the architecture, which is underlying the particular software, ought to be documented. I've taken this without mentioning the name of the company for reasons of non-disclosure agreement that I have, but I have taken it from some of my consulting work. Next file, please. Finally, I have given 3 case studies. The first one is actually a full web-based healthcare system. It is entirely explained in the context of the UML-based design model, so that what I have indicated as the basic modeling concept, in fact, is shown to have been used in a practical system. The most important consideration in this case, in this particular context, is that the design ought to evolve and align itself with the domain's information flow. So, for a banking domain, the bank's domain information flow is very important, and the design ought to be aligning itself to make either that more efficient, that particular information flow, or more meaningful for the user. I have taken a second example, which is a little more into the networking area, particularly the subnet configuration and configuration management in the context of a multi-team agile and test operation. So that's the DevOps scenario. The third one is a full-fledged embedded graphic system for distributed display panel management. You would have seen very large displays with part of the graphics coming on one segment and the other part combining with it from the previous segment. So that is the kind of very large graphics distributed display panel management is the third case study. So these are the case studies, and I think this is the last chapter in the book. So maybe just move on to the next point, please. Well, here I am giving you my contacts, and if you will like, you could always reach me. I will be happy to mentor if somebody is thinking of writing a book, or I can even collaborate in book writing. Next point, please. I should like to thank the organizers, CSI, IEEE, and ACM, particularly Dr. Mohan, Professor Muthukrishnan, Dr. Akila, and the team at PHI, the Ghosh family, whom I have known for now for more than 4 or 5 decades now, Ashok, Sagarika, and Pushpita, and Shivani, of course, Ajay Das, and the production staff at PHI. The people who helped me in making the book possible are Ravi Mittal, Naresh Saigal, Ram Rastagi, Arun Mehta, Srini Padmanabhan. It should be Naman Patel. I'm sorry, I have written Nitin Patel. Nitin is another person that I know. It should be Naman Patel, Dr. Shyam Vasudev, Shushant, and his team. I will also like to thank Professor Radharaman and Ramani to have graced this particular book release. I think I'm by and large done with my presentation. I'm sorry that I exceeded my allocated time. And I will be happy to take any question answers. the organizers had submitted some questions. So I think maybe if the questions are addressed to me or to, depending on who they were addressed to, I'll be able to and will be willing to take as many questions as possible. I think I'll skip that particular point, but that's okay.
Thank you, Professor Bhatt, for your excellent presentation and given the outline of the book, how it has been written and what it covers. And so basically, I could see that the entire book looks like an encyclopedia. And starting from the beginning till the end, and giving various aspects of software engineering, including modeling and so on. So thank you very much. And now I request Dr. Sakthivel to take over the Q&A moderation session. Dr.
Yes, sir.
Sakthivel, please.
Yes, sir. Thank you, Mohan, sir. So, Professor C.R. Muthukrishnan, sir, has presented the overview of software design, architecture and engineering, and Professor Bhatt has presented the overview of his book. So, there are some questions. I will read out the questions and we will get answer from Professor Muthukrishnan and Professor Bhatt. Sir, do we need to keep any special consideration while designing the mobile application architecture for artificial intelligence technologies? Shall I repeat, sir? Do we need to
I
keep...
think the question is understood. Is Muthu going first?
No, you go ahead. Yeah, I saw this question in the list that was sent in by.
Yeah, okay. I think what I like to indicate is, okay, let me now, get to this particular question, which is how one can make a system appear more intelligent. I will indicate to you one consulting work which I did, and then I will also give you an example which is more contemporary. So let me give you first a very old example, something like 40 years ago, or 30 years ago maybe. One of the things that used to happen when you travel to Europe or England, if you were, let's say, lodged in a particular hotel and you called for room service from your room, the person would straight away say, look at the room number and straight away say Mr. Bhatt or Mr. Gupta or whoever. But in India, we didn't have that facility. So the consulting work which I did was, using a 8-bit microprocessor, have a small 7-segment display so that when the exchange at the reception receives a particular room call, the name gets associated with the room number. So it's a very simple thing. It's a very, very simple thing. You could use a 8-bit microprocessor, 7-segment display, a very simple system in which when room number 303 calls, Mr. Gupta or Mr. and Mrs. Gupta are staying in that, and you could respond, yes, Mr. Gupta, what can I do for you? Instead of saying, yes, room number 303, what do I want? What do you want? So you see, this makes the system appear intelligent. The point I'm trying to make is it's only making, once you set for mobile application, it's very important for you to say as to what is the specific need that you are addressing. If, for instance, in a more recent, just before Paytm and others came in, I was a consultant to a company which was developing a small gateway. But at that time, what we were doing was, we were using a small hardware dongle in which we would encrypt the password, which will allow a user to use multiple banks from the same cell phone using a common gateway. So the idea was very simple, that you create the password, you have an ability to connect to HDFC or to ICICI or to State Bank of India, whoever you want, and your password will be in your hardware dongle. So it was possible for you to create a very simple mechanism Now you can say that now, the system is by itself intelligent to be able to figure out which bank you are, you select the password and which bank you're connecting to and whatever transaction you want to make. Now, point I'm trying to make is that once you have an idea, it is very important for you to make it appear intelligent by augmenting a certain capability so that it caters to the need of the user. And that's when it becomes like a typical, AI system, or I can go on to talking about the machine learning capability, but I think I'll stop at this and let Muthu respond in case he has anything to add.
Yeah, I like to briefly add just one point. You see, I think the question, can you hear me? The question is about using mobile devices and bringing an AI kind of application to serve people and so on. I think the I think the key point, if I understood correctly, is that mobile devices are they may have lots of memory, no problem about that, but they're not really adequate to let's say to compute a neural network. That has to be done. So it's like you have to develop it elsewhere, but then bring it to the app. But then if the app has to access large amounts of persistent data in order to provide an intelligent response to something, like say, for example, medical diagnosis or something like that, it may not just be, it may not just be a simple classification problem. It might go beyond that. That's also possible because the app most mobiles sit on a network. Why most? All of them sit on a network. If it doesn't sit on a network, it's not a mobile, right? Therefore, it can go on the network and access those databases, but there are issues of performance and so on, okay? And with 5G rollout, I don't know how affordable it will be. It might take quite some time, but it's possible that with the kind of network speeds and bandwidths and so on, low latency and things like that, hopefully, no big body will thrust net neutrality down the side. I think this is possible. Even common people can access through mobile devices AI-type applications. There are two components to an AI application. One is the processing logic, which you can develop and bring it here in the form of a network, whatever it is. The other one is the access to a database. That can be done by being on the network.
Thank you, sir. We'll move to the next question. How to gain the knowledge about software architecture?
Study interesting software. For example, Skype. How many of you know how Skype originally was implemented? It's been taken over by Microsoft, but earlier, first cut, it was a piece of software or application, whatever you call it, developed by some European group. You know how it was done? They didn't have one large computer to do Skype service. They actually gathered suitable participants from the network and built a logical network by which the Skype service was done. These are all available, so all you have to do is to study some interesting cases. You'll get a lot of ideas. And do you know of any good fiction writer who has not read good books? It doesn't just come out of thin air. So I think one way to study good architecture, of course, some basic principles are there. How do civil engineers study architecture, for example? A good civil engineer wants to go to Chicago and spend months, or he wants to travel, They want to see things and gather experience. So case studies. I think that will tell you a lot about architecture. Trying to fit everything into a few standard models could be a good starting point, but you have to go beyond that.
Thank you, Professor. Next question. What ails the Indian higher education institution and why even premier institutions fail to develop large-scale software?
Now, this is by Vishwakarma. I know that. I flagged the question. You see, we have not attempted development of software by institutions. Unless we attempt, we can't say we have failed. There's no ecosystem, you see. I mentioned a few examples of software developed in India for applications using whatever resources were available at that time. Of course, they all have transformed completely over the life cycle. MCA 21, for example. So if you look at the domestic, nowadays income tax in India is developing a lot of applications, a lot of software and so on. So the question really is whether we are developing infrastructure software. That I think is a trickish question. One has to look at it very carefully because infrastructure software requires a very large install base and footprint to be really successful. Okay, I'm not saying in terms of making money and so on. Why is Microsoft able to support, in spite of all the network vulnerabilities and security issues and all kinds of attacks, vulnerabilities, and so on? Because they have the resources to do it and they have the install base, which is compelling them to do it. I'm not a proponent of Microsoft. I'm not working for them or selling. So I think you need that install base, and I think that has to be created. We are doing some good work in that. For example, now we have our own chip design, which is big. One technique that's used is to open source some of the things so that there will be a community-based development. We have not attempted enough of that kind of model yet in our country. But I think in the next 1 or 2 decades, these things will start happening in our country. We are moving through some inflection points positively.
Thank you, Professor.
Don't ask the question why we failed. Ask the question how we can succeed. That's my position.
Thank you, sir. The next question: What are the latest design patterns and its advantages?
Please repeat the question.
What are the latest design patterns and its advantages?
I leave it to Prof. Bhatt.
Well, I think, the design patterns are essentially the code writing patterns. Very few of them are, there are there's a book on design patterns. There are several books on design patterns, and it was developed by Eric Gama and other people. The point that they really meant to emphasize was that there are certain patterns in the code that you write for a set of applications or programs that you may have. For instance, repeatedly it would seem that table lookup is something that you may have to do several times over. So can you now optimize that? Can you now give a pattern to that? And can you have a code structure which will help you develop that? This is the way the design patterns themselves have emerged. The most commonly used pattern, I think Professor Muthukrishnan mentioned about MVC, for instance, model view and controller. This is one of the patterns that very often used, particularly in the context of embedded systems. And so depending upon the nature of the usage, there are certain code patterns that have been developed over years, and those are the patterns that have remained unchanged so far. The kind of thing that probably, in my view, have changed is the patterns of coding that you need to follow when you use a language or you shift from something like C or C++ to a language like R or Python, and where you use a different set of packages which are embedded with so much of capability. I'll give you a very simple example of how Pythonic thinking differs from C++. For instance, A, is it same as B? In C, you will check it by comparing the pointer to A with a pointer to B. Whereas in Python, you will simply check for A is B or true or not. Now, this actually completely elevates the level of abstraction, because then you're talking in terms of objects and object relationships, and you capture the relationship pattern in a Pythonic thinking. So what you try to do, for instance, I gave you this example of A is B or A compares with B is in terms of equality. If A as a variable is 5 and B as a variable is 5, and these are two different variables. These are two objects with this, which are equal, but in terms of their current state. However, if A is pointed to by a pointer and B is pointed to by a pointer, and they are different, then they are different. Otherwise, A is B. Now, this can be captured straight away in Python. So, in Pythonic thinking, the level of abstraction that you use is different, and therefore the design pattern that you use is different. Instead of the low-level design patterns, which is what Eric Gama and all these people had talked about, you have to move one level up and go to a level which is one level higher in terms of the abstractions for you to evolve the patterns of usage. And this is largely what is being used currently by the data analytics people. I think I'll stop at that unless, of course, Muthu has something to add.
Thank you, Professor. The next question. What are the benefits of this book in the industry-related works?
I have indicated in the book that if you look at, I think I had emphasized the case studies. The three case studies that I have talked about, for instance, the one which is on the healthcare, it talks about the healthcare taking care of the concerns of the patients, doctors, the mobile apps, the administration, the IT systems, and it also, talks about the manner in which the digital health platform can be utilized for purposes like medical consultation, and also, so point I'm trying to make is that, in fact, I've indicated that how the anyway, let me not get into that. The basic point that I'm trying to make is how this particular system has been developed using the UML diagrams from scratch for the concerns of all stakeholders, the stakeholders being patients, doctors, the hospital, including resources like operations theater, and so on and so forth. So the point I'm trying to make is it is possible to have a architecture evolve from a model that you can have for a system. And in this particular case, the idea was to have a web-based healthcare delivery system, and then create a model from the UML diagrams for the software to be designed and then delivered. And this is being used, I may mention, by hospitals like Narayan Hridayalaya in Bangalore. I don't want to mention all the hospitals that are currently using it.
Thank you, sir. Next question is a general one. How to publish the book with all commercial aspects?
Shivani will take that.
I think, may I respond to that? Book writing is and Professor Rajaraman probably would have been an ideal person to respond to this question because he wrote so many books. He probably has now probably more than 25 books or so. You should have a particular passion to write a book because there is a particular understanding you have of the area you are working in. I wrote this book because I felt that in the industry there is a lot of ad hocism, and the ad hocism leads to poor program and software development. So I had this desire to try and position a book in a manner that the industry professionals can take a look at it and become what I define as a thinking architect for a software. There should be thinking architects, not just driven by the anxiety that we have to deliver such and such software by such and such date, and when will you finish this program? That kind of an attitude is creating tensions amongst the managers with the software engineers. That's a huge, huge problem that I have noticed in the software companies in Bangalore, and also in Hyderabad and Chennai, where I had been, going every month for a period of I think something like 4 years almost.
I think the one-liner for that is that
The commercial aspect, and that is if you want to really make quick money, you can write a book which can actually be on whatever is the current rate. You write a book on whatever is the current rate, and then you sell it. That's a commercial aspect. So my sense is that if you can, if you have a desire to write a book, and if you are a serious professional, you should write based on what you have been experiencing and where the shoe pinches, and try to address those issues in the book. If you want to write a commercial book, you can just write user manuals, and they will sell, very easily. I think that's my response to that question.
Thank you very much, sir. The next question is...
one-liner for what Professor Bhatt observed, the industry situation, managers and developers. The one-liner is managers over-promise and developers under-deliver.
Thank you, sir. The next question is, what are all the areas related to software design, architecture and engineering?
What are all the areas?
Research areas related to software design, architecture and engineering.
Research area, okay. I'd like to mention security is a big concern now, especially in the infrastructure, software for software architecture. There are huge projects and big investments going on in, of course, some of you might have heard of this trusted computing platform and so on. BIOS has been replaced with EFSI, all kinds of things have happened. There's some progress, definitely. But they're all, based on not thinking about security as a requirement to start with, but as a response to something in terms of experience in the field. All right. It's like the way we are dealing with pandemic, for example. But security is a big issue, particularly with the internet and the kind of spread that is happening. Everybody wants to leverage the net for all kinds of things. Anytime, anywhere, all kinds of things. And I think the security is becoming a big issue. So, what architecture? It's a total picture. It's not just software architecture. It's a total picture of what architecture, system plus software together, can guarantee much higher or can assure security. This is a big area of research, and I think the project is called Pluton or something like that. There are new chips being designed. See, what is happening is that the trusted computing chip, or whatever you call it, trusted platform, and the current processing units, they still communicate on a bus. And that is where, people have found some ways to sort of break it. All right? Jailbreaking, whatever you call it. So therefore, there is a lot of interest now. And I think in the next few, for example, you ask the question, what is so special about Windows 11? Are they going to be something very exotic, something very new, or is it just going to be frills? We already have a lot of user interfaces. Something is on the center, something is on the left, all kinds of things. Apple has a menu on the screen on the center. Windows is have it on the left. That's not it actually. Windows 11 ultimately will have the potential to be run on Plutons. So, in fact, the way they are announcing it is that you need to have an initial verification of whether your system is suited to run Windows 11. They're allowing some more flexibility to start with, but progressively you will have to go into the different total infrastructure configuration to guarantee higher levels of security. This is a very important area of design, architecture and design, but it is integrated.
Thank you, sir. Next question is related to security. How does security and privacy by design impact architecture lifestyles, real-time applications?
I think my response to the previous question is connected with this.
Okay, sir. Thank you very much, sir. Next question is, which computer softwares are best to use?
Whatever you like. Whatever you're comfortable with. See, you all go through some learning curve, right? And we don't use much of what the software is able to provide. We use some of it. at the retail level. But if you're working for an organization, so that's what we call power user, novice user. So there's a learning curve, adaptation curve, and so on. So it's not something that you can get somebody else to answer for you. You have to experience it. You have to sort of wet your feet and jump into the water a little bit and so on. You can be an early adapter for something. There are opportunities. Some of the software gets released on trial basis, beta users, inside users, and so on. So it depends. But if you're looking for something very specific, then you can ask for recommendation through some consulting, which of course has to understand your side much better, much deeper.
Thank you, Professor. Next question. There is a plenty of literature on each of the following: architecture, object-oriented design, mathematical modeling, programming practices and paradigms. I have felt that there have been very little discussion connecting these topics. Will we see some convergence between these disparate conversations in the book?
To connect these topics, you need a intensive course. You can't do it in a book launch program, actually. But we did indicate, we're not explicit about how these connect. But you have to look at large system, large scale, evolution, maintenance, and how do you produce new versions and things like that. There are a lot of issues. Yeah.
So these are all some of the questions we have received from the participants. Now over to Mr. H.R. Mohan for...
Mohan, if you give me a minute, I did mention about exciting things. I left out one. I said it's not on my slide.
GPT-3, I wanted to ask question.
Yeah. PPT-3, you can share it because the links are there. But this one, I've not given a link in the PPT. This is actually from GitHub. GitHub has just last week introduced in a special launch program, in a special invited program, whatever you call it, something called Copilot. This Copilot has been created using OpenAI. And OpenAI is a machine learning, deep learning software available publicly. And what has it generated? It has looked to a lot of open source code. When I say a lot, it runs into not millions but billions of lines. In a structured manner, they put a lot of work. It's not just pushing the code onto that deep learning platform, deep OpenAI platform. And it has come out with some kind of a structuring of this code. So what happens? The way you use it is the following. There is an assistant now. If you write code, depending on what you're writing at some point, this thing is looking over it like when you edit a document, somebody is looking at it, flagging things in red. The spelling is not right, this construction is not right, etc. So it will make suggestions to you from its own digested open code. It will make a suggestion to you. And you know how they are promoted. There are developers who are very much upset about it, as I've reported now. This is very, very early. And there are some developers who are very excited about it. And how did they project it in this meeting? As pair programming. Professor Bhatt mentioned pair programming. Two people sitting together and putting their heads together. But this is a pair programming, but one of the persons that is pairing with you carries a lot of real database, access to the database in an artificially intelligent manner. Very exciting development. Please go and look up GitHub and type in Copilot. You'll see some interesting stuff.
Okay.
If possible, I'll add that link to my PPT so that it can be sent to other people.
Thank you, Professor CRM and Professor Bhatt. And just want to add one more question from my end. What are the challenges in refactoring the code and maintaining legacy software?
Yeah, Muthu, you want to take it or shall I go ahead?
Yeah, it will be better, because now with so much changes are happening.
Yeah, I think you have a very valid question, and I may point out that let me cite an example that might be interesting. You know that there's a lot of legacy code, both let me take a simple example from Unix, for instance, grep, or one of those Unix tools that are used, like awk or others. And these can be then put in a capsule with an API. The same thing has been done by Microsoft when they moved from one generation of the disk operating system DOS to another generation of DOS. That is, there's a lot of legacy code which is taken with a plugin with an appropriate boundary that only certain parameters shall be taken in to be able to get this particular behavior and then move to a higher level of abstraction. That is how in the operating system a lot of code actually gets transported from very low level codes into packages that become available at a higher level. And what I'm trying to basically say is for the legacy code to be carried forward, there's a lot of APIs that need to be developed, and a correct API can enable you to carry forward the legacy code.
Okay.
I think maybe somebody like Ramani, maybe, if it is possible for him to comment upon it, or Professor Muthukrishnan might want to comment upon it. But refactoring is something which is done very commonly, and a lot of API design need to be done carefully for large systems in particular.
Okay. Thank you. Professor CRM, this will GPT-3 will replace software developers. You are muted. Please unmute, sir.
GPT-3 is a generator. It's a very exciting thing. They push a lot of text, literally, billions of pages, billions, maybe even tens of billions, or maybe, I don't know. And then it's a very large network. I think maybe I'm mixing up things, maybe trillions of pages and billions of gates, something like that, neurons or neural net. So it's a very large network, and they really used up enormous and fantastic amount of computing resource, and they came out with this transformer. It puts out text by digesting all those texts. I think they have done it for English. I think when the Turing test came, can machines be intelligent? The following question was asked. If you put a monkey before a typewriter and it just goes on typing, will a Shakespeare's play emerge out of it sometime? That was a question. And I believe with GPT-3, it may happen. We are closer to that, answering that question. Maybe, we are being closer in an infinite dimension that I don't know. So this GPT-3 is now, initially it was open sourced by OpenAI, but I don't know, now there is something going on there about licensing, how to license it and so on. But it can digest a large amount of text and written material, structured material, and so on. I'm sure later it will get extended to pictures and also, and then it is able to generate out of that and propose, right? We only know recognizers, right? Good recognition, classification, but this is a generator. And therefore the question that Mohan asked is whether GPT-3 can generate programs, code, and so on. GPT-3 may or may not. I don't know whether anybody is trying. It's a big project. A lot of resources will be required to do that. But this co-pilot that's put on GitHub is on those lines, actually. It is a deep learned network which is digested for generative purposes, suggestive purposes, not generative, suggestive purposes based on a sample that a developer is coming with from its own digested network. So it's a generator, but the generation is based on the current input that the developer is putting up on the screen. I've already put the link for Copilot on GitHub in the chat.
Yes,
please pick it up.
Okay. One last question, sir. Which is the correct age to learn or teach software development or coding?
Correct age?
Either to learn or teach. Now, in schools, they started teaching right from third standard and things like that.
Yeah.
which is the correct age.
I think starting early is a good idea, but you have to do it in the right manner. Don't teach C and C++ and so on. There are a lot of fun languages which teach the idea of how you program. In fact, if I mean, you might be surprised that I'm mentioning this. If you look at a first course on programming, or one of the courses on Introduction to Programming in MIT, in the OCW, Open Courseware, it's not for engineering computer people, it's for general people, probably liberal arts and things like that. They make it a fun exercise by using a special machine which has some instructions and so on. There are lots of stuff like that. I'm sure Ramani would know. Seymour Papert worked on that, Sketch. And then there's something from CMU, which Jay Kesavan used to promote and so on. So you need to pick those kinds of programming is about being able to envisage a set of instructions and organize it in a manner so that you can produce something, achieve something. So don't jump into languages and practical stuff at that stage. Just get the children to think in terms of, just like they learn to speak, communicate, let them learn to communicate, let them learn to pick up how to use a bunch of instructions in a cogent manner to produce something effective.
So basically, computational thinking we have to establish. Right?
Yeah, you're right.
Yes, may I just add one small thing?
Programmability. I think programmability is a great concept. Programmable and programmed machines are going to pervade everything.
Yeah, I think a good starting point.
There's no escape from it. Yeah.
That is.
I could just mention that, my grandson uses Scratch. And
Scratch. Scratch is a good example.
Yeah. And he has been able to program robots to function using Scratch. And he has participated in a robo competition.
Yeah.
And now he is trying to create a product using a 3D printer. But he is still programming in Scratch.
Okay.
Yeah, this kid
Thank you.
Ramani, would you like to offer some remarks from your experience?
Yeah, I think Ramani should be speaking something with having been.
I can't let go of an
I have unmuted. CRM, thank you for calling me. I just wanted to add a response to what Mohan asked. What is the right age to learn software engineering or to teach it? And it appears to be, again, PCP has been, Bhatt has been using examples. That's a good way of answering a question. So I will also use an example. What is the right time to teach a mother to be about child development and how to bring up a child? I think it is, you just wait till the woman concerned has had one child and has brought it up to the age of 2 or 3, then teach her a course on child development so that she will take care of the second child. Partly because child development is not a theoretical subject. Child development is very practical and you have to have gone through it. And unless you have gone through it, if you get a bunch of unmarried girls into your class and teach them about child development, it would be very theoretical. You wait till they work with the children. So similarly to me, it appears the right time to teach software engineering is let the guys who come out of college go out and work for 10 years somewhere, 5 to 10 years. And then come and attend a course in software engineering. Because you must have been out in the world, found the problems, so that when the teacher talks to you about the problems, you understand what it means. And it is not something in the air, it's something from your own life.
That's an excellent suggestion, but industry won't send that person. And they will push him to the level of incompetence.
May I have just 1 minute to mention something which I think might be of general interest. There was a question about AI and use of AI technology in the context of mobile app. I should like to mention a recent award by the Apple for an innovation by an Indian whose name is Ranade, who was a student of Pandit Jasraj, and what he developed as an app which uses AI technology is if you are singing, then there can be, if you want an accompaniment of a certain instrument like flute, then your singing and flute will go together. Several such, and in fact, he can have percussion instrument, and if you slow down when you are singing, the percussion instrument by itself slows down. The point I'm trying to make is it follows your method of singing and rendering the song. And that is an application of a use of AI technology, and it's a mobile app. This app has been developed by Mr. Ranade, who used to work with Google earlier. He and his wife both have developed. They are students of Pandit Jasraj. Pandit Jasraj is no more, but this is an excellent example of use of AI technology in the context of mobile app.
Thank you. Thank you, Professor C.R.M. and Professor Bhatt, for your excellent presentation. On behalf of the organizers, CSI, ACM, IEEE, CS, and PHI, our sincere thanks for your time and effort in making this session a memorable one for all of us. And thanks, Dr. Ramani and Dr. Rajaraman for joining the session. And before we formally wind up our today's session, I just want to make an announcement about our next program that is slated on 4th Saturday of this month. It is on a book release, 10 questions for personality development. The book has been authored by Major General Tajuddin, who is a fellow of CSI, and he will be presenting a talk on 10 questions for personality development also. And the book will be released by General Bikram Singh, former Chief of Army Staff. So this program is on 24th. We have already started circulating the invitation. Please do register and join this program. So once again, thanks to everyone for making this event a memorable program. And with this, we'll close our today's session. Thank you very much. Good night.
Good night.
Thank you all. Thank you all.
Can we leave the meeting now?